In this tutorial, we have actually 4 problems. So they are related to one second. They are related to Galilean transformation actually. Yeah. So in the first problem, consider a main moving on this train. So the train is moving horizontally forward at a speed 20 meter per second. So this speed is given to us with respect to the platform, and the man holds a ball from of this mass 0.5 kg is given to us, and it says that its initial velocity was actually initially 0. The ball was having initial velocity 0, and finally its velocity is changed to 10 meter per second with respect to the man. Okay, this is given to us, and it is also said that the man throws the ball horizontally towards the front of the train in the direction of the train's motion, like in this direction. Now, when Owen observes the event standing on the platform. So this is the Owen observing from this. Now we have to find what is the work done on the ball according to the man, and also from here. Okay. So these are the 2 questions we are having. So as you see, this girl is actually here on the platform. So let us consider that this is from S frame, and the person which is on the train is basically S prime frame. Okay. So from S prime frame, we want to find what is the work done. So S from S prime frame, we are saying that we can see that the ball is actually having initial speed this much and final speed this much. So what will be the work done on the ball?
Change in kinetic energy half into 0.5 into 10
Yes,
square.
change in kinetic energy, which will be nothing but half into mv final square minus half mv initial square. If you substitute the values, then it will come out to be equal to 25 joule. Now, if you look at from S, what will be the speed of the ball, initial speed of the ball with respect to S? It will be the speed
20
of the
meter per
ball
second.
with respect to that person plus the speed of the train, right?
Yes.
Simple relative velocity concept. So which will be nothing but 0 plus 20, because this u is given to us to be equal to 20 meter per second. So initially the speed of the ball, that S will see that it is having 20 meter per second. Finally, the ball speed is changed to 10. So final speed will become 20 plus 10, which is nothing but 30 meter per second. Now, if you calculate the work done on the ball, let me make it W prime here and WB here. So what will be the work done according to this S frame?
500 by 4.
Same formula, change in kinetic energy, which will be nothing but 500 by 4, 125 joule. Now you see, there is the answer of A and B are actually not same. Is it possible or not?
Yes, because we are not talking about total energy.
Yes, it's
Yes,
possible.
we are also saying
Hmm.
taking the work done by train's engine on the ball.
Yes. So that's why you cannot say that it has contradicted Newton's mechanics. Okay. So what is this difference now? Why is this? Why there is 100 joule of difference in both the answers?
Because in train frame the train is not moving, but from the station frame the train is moving, and that's why the work done by train on the ball is also in the picture from the
Yes,
station frame.
exactly, exactly. Okay. So is it clear, everyone?
Yeah,
Yes,
this will
yeah.
take some time to understand by everyone. So there are two different scenarios here. Yeah. Is there anyone facing difficulty here? This is very important. Otherwise, you will struggle all special theory of relativity if you do not understand it.
So if you actually write the work energy theorem from S prime and also work energy theorem from S, it should not actually contradict, right? Work from S prime or S, both should give correct expression. Like work, what is the work energy theorem? Work energy theorem is work done by all the forces must be equal to change in kinetic energy.
Yeah.
So this should actually be true in both the cases. We don't care what is the delta Ke in S prime and what is delta Ke in S. We just want that W should be equal to delta Ke in S prime as well as W should be equal to delta Ke in S, both. Okay.
Yes, Bhaiya.
Yes.
So if you try to find what is the work done, we will find like this, right? But whatever the force is being experienced on the ball into displacement of the ball, right? Suppose the ball was actually, because it is changing its speed, there must be some force. So let us suppose that this force is actually F is equal to ma kind of force, where a is some constant. So this we can write as ma into delta x can be written as x is equal to
T
ut
square
plus
minus.
half at square. So
Yeah.
initial speed of the ball in S prime was actually 0. So we can simply write it to be equal to this much. This will be the work done on the ball, half m a square delta t whole square from S prime free. Okay, now let us also try to write what will be the change in kinetic energy from S prime frame. So that will be half m vf square minus vi square from S prime. So which will be nothing but v square, v is equal to u plus at again. So we can write a delta t. So you see, from S prime, we are actually getting W prime is equal to delta K prime. So it is, work energy theorem is true in S prime. Similarly, if you do for S, you will get the same thing, right? Work done from as observed from S will be equal to F into delta X, ma into delta X. But here from S, we will see some movement due to the strain also, right?
Yes.
So
Yes,
this will
Bhaiya.
be u due delta t plus half a delta t square. So total work done as observed from S will be this much. Is
Yes.
it correct?
Yes. Yes, Bhaiya.
Huh. Now if we try to write delta k, that will be half m vf square minus vi square. Again we will substitute. Then if you see, both w and delta k will be same from S also. Okay. Now if you, this 100 joule is basically coming because let us write this value. So delta k will become half m vf square minus va square, which will become half m vf is basically u plus v is equal to u plus a delta t whole square minus u square. Is this correct? V is equal to u plus a delta t. Yeah.
Yes, sir. Yes, Bhaiya.
So same expression will come out.
Yeah, you are going mute again and again in between of sentences.
Oh, wait. So, so my voice is not continuous?
Now it is continuous. Yeah.
Okay.
Yeah.
Okay. Now, if you actually subtract the work, this work done from observing from S and work done observing from S prime, you will see that. So let us subtract. So we will find that it is coming to be equal to M A U delta T, right?
Yes, Bhaiya.
So which is nothing but F times of the work done on the train itself, right? This is the displacement of the train. Ma is the force. So this change in work done is basically the discrepancy, the difference between the both work done is nothing but the work done on the train, right?
Yes. Yes. Yeah.
So which should be true actually. The work done on the ball as observed from S is nothing but work done on the ball as observed from this S prime, right? Plus work done on this train as observed from S, right?
Yes, भैया.
So this is what we are actually checking. Now, in question number 2, is question number 1 clear to everybody? It's very simple.
Yes, भैया.
Yeah. Now, in question number 2, we are given that consider friction between the main and the train floor. So we have some friction in between. Now see, you cannot actually change your speed from 0 to 10 unless you apply force on the ball, right? But this force, how will you apply if there is no friction in between this person and the train? Then you cannot apply the force to the ball. Are you? Will you guys agree with me or not on this point?
Yes. Yes,
Yes,
भैया.
Bhaiya.
Yeah. So now suppose the person is standing here, the ball is here, and we are giving some force to the ball. So the ball is experiencing F force like this. So the ball will give the person a reaction force F like this. Okay. If there is no friction, then the person will move along this way. Are you guys with me?
Yeah.
Now,
Yes, भैया.
so the friction will actually help the person not to move, and the person will experience a friction force along this direction, and because of the person, the train will experience a friction force along this direction. This picture is clear or not to everybody? Let me know.
Yes, it
Yes.
is clear, भैया.
Yes,
Yeah.
Bhaiya.
So now, as we know that the person is not moving on the train, so this F is nothing but equal to the F. So this F is actually coming because of the friction itself. Do you guys agree with me or not?
Yes.
So this force, whatever force we are giving to the ball, is coming only because of the friction. Okay.
Yes, भैया.
So now see, consider a friction between the man and the train floor. So we have already considered, and thus the ball. Why they are saying in bracket that the ball? Because this force is nothing but is coming but because of this friction. Next, consider that the applied force provides the ball same acceleration over the same time. Like whenever it was changing, this speed was changing from 0 to 10, right? So in during this process, the force applied is giving same acceleration all over. But that means the acceleration was constant. This is also given to us. Now, note that there is no change in initial and final kinetic energy, but an extra force needed to oppose the friction. So from here we can say that this initial and final kinetic energy has not changed. We are just putting friction to make sure that the person is not moving. and this scenario actually is physically possible to see that this scenario is actually physically possible. Till now it's clear.
Yes, yes, भैया.
Yes.
Yes.
Now we have to find the heat energy developed in is same for each observer or not. So what will be the heat energy developed? It will be due to the friction itself. So let us calculate from S prime, that person frame. Yeah. So from S prime, what will be the work done by the friction?
0.
Work done by the friction is, now see, at this point we were applying friction, like friction is was applying at this point, but this friction has some effect on the ball, and we are actually able to transfer this effect of friction from here to here, right? And this ball is getting some displacement delta x prime.
Yeah.
So that's why we are actually utilizing this sentence from this question, that consider the friction between the men, like this friction. We are also saying that the same friction is actually being applied to the ball. Okay.
Yeah.
I also thought like the same in the initial cases, like if the force is not being applied to the ball, like if the friction is not directly applied to the ball, can we simply write work done by the friction to be equal to 0 or not? But because here it is said that this friction is nothing but the same force on the ball, so this ball is getting the force only from the friction. That part we are trying to say. Now,
Mhm.
can I write this thing or not? F into delta x prime. Work done by
Yes,
the friction will be equal to F into delta x prime. Can we write it or not?
yes, yes, totally.
Yes.
Yes, yes, भैया.
Yeah. Now, if you try to write this, the work done, this will be, now let us simplify. F is equal to our m into same thing. F in m into a delta x prime will be equal to ut plus half a delta t square. This will be the work done due to the friction from S prime. So this will be the heat energy generated from S prime, right? So this
Yes.
is the heat energy from S prime. Now let us try to find from S. So for the second part, like from the S frame, if we try to write the work done, it will be force of friction into the relative displacement between the ball and the train. Right? So the displacement of the ball minus relative dis. So this is the relative displacement we are writing. The displacement of the ball minus displacement of the train. So if we do same way, so displacement of the ball will be, initially it was having some u delta t plus half a delta t square, and displacement of the train is u delta t. So the work done by the friction is equal to same thing, m a half a delta t square. So work done by the friction as observed from S prime and S are both same. So are you guys with me?
Yes, yes, भैया.
Yeah.
Yes, we are.
So now in the third part, in B part it says that according to the ground observer, in addition to developing heat energy and increasing the kinetic energy of the ball, the applied force does work on the train itself. So this applied force, whenever he is throwing the ball, he is also applying some force to the train itself. So now we are supposed to compute the amount of this work. What is the work done on the train because of this applied force? So what will be that?
M and U delta.
Yeah, force m into a, and the displacement of the train is u delta t. This much will be the work done on the train due to this applied force. Okay. Next, is there an equivalent performance of work by the observer on the train? So is there any equivalent amount of work due to the observer S prime?
Yeah, because that displacement does not occur in the observer frame, in the train frame actually.
Yeah, so that will be zero. So there
Yeah.
will be no work, no equivalent work like this. Okay.
Yeah, yes.
Okay, I think rest of the two questions will not have any debate at all, I'm sure. So we can go fast here. A pilot plans to fly due east from A
Actually,
to B.
debate is good. Only thing
Yeah.
making it to understanding is little different for everyone.
So the pilot plans from A to B and again comes back. The velocity of the plane in air is u prime. So the plane can have u prime speed, and velocity of the wind with respect to the ground is actually v. It's given to us. Now this distance is also given to us. It is L. Both u prime and v are constant. This is and this both are constant. If v is equal to 0, like if there is no wind, then so that the time for the round trip is 2L by u. This so time taken to go from here to here and again coming back to here we have to find in first part. The time taken to go from A to B will be equal to distance divided by speed. So L divided by u prime. Time taken to come from B to A will be same distance with same speed it will come. So total time it will take will be equal to 2L by u prime. Everyone agrees?
Yes, we are. Yes, we are.
Okay. Now, if the wind is from west, what is the time travel time? What is the time travel time for a round trip? So let us north, south, east, west. So the speed is wind is like this now. So what will be the speed of the aeroplane when it goes from A to B? So it will have some extra speed due to this wind. So it will be u prime plus v. Everyone agrees?
Yes, Bhaiya.
Okay, good. U prime plus v. So time taken will be this much. When it comes from B to A, its speed will get reduced. So u prime minus v it will become. So time taken to come from B to A will become L by u prime minus v. Now if you total it, total time taken will be equal to this plus this. So L by u prime square minus v prime square to u prime. So if we simplify it, it will become 2L by u prime divided by 1 minus v square by u square. This is just, we are just writing. So this time is nothing but the, let us consider this t0. It will be t0 divided by 1 minus v square by u square. So this is just algebraic simplification. Now third part. If the wind is from south to west, then compute the travel time. Now suppose the wind is like this now. Now you see the plane should reach B. If the plane starts like this, because of wind velocity v, it cannot reach B point, right? Because the resultant velocity will be like this. So it cannot reach B point. Everyone agrees here?
Yes, Bhaiya.
Yes, Bhaiya.
So that means this plane should move in this direction so that the resultant points in this direction. So that it can reach the point B. That means, suppose this angle is theta, then the component of plane's velocity along this y direction must be balanced. So u prime sine theta must be equal to v so that the plane can reach from A to B. Now, if you know this, then the speed of the plane along AB direction will become, when going from A to B, will become basically u prime cos theta. So if we simplify this, it will become u prime 1 minus sin square theta, u prime 1 minus v by u prime whole square. Yeah, this much will be the speed. Now, again, when coming back, again, its direction should be along this, so that the resultant of the wind velocity and aeroplane velocity along this, and same magnitude of speed we will get while coming from B to A. So total time will be distance divided by this speed, which will be 1 minus v by u prime whole square. So this will become t0 by root over of 1 minus v square by u square. Part C is also clear. Anyone having any doubt?
No, game.
Okay. Now, should
Bhaiya,
the
can you
two,
tell once more why u dash sine theta equals to v?
because so v is along this direction.
Yeah,
Suppose we
yeah.
are going along this direction at an angle theta. So the component of velocity along this direction will become u sine theta,
Okay, okay.
along this direction u cos theta.
Yeah, yeah,
If
got
there is a misbalance in y direction, there will be some resultant in the y direction, and there
it.
will be some additional displacement along y direction if there is a mismatch in v and u sine theta.
Okay,
So
okay.
if they are equal, then this displacement will be zero.
Yeah, yeah, got it. Thanks.
Next, should the two travel times b and c be equal? Anybody?
Bhaiya.
Yes.
How is this VAV is equal to U dash cos theta?
VAB while going from here to here, so finally it is going with speed u cos theta.
Okay. Got it.
Now these two should not matter, right? These two are different situations, so they should not be equal.
Yes,
One
game.
wind velocity is along this direction, another one in this direction, so they are different situations. Okay. Next, question number 4. Question number 4. Anybody knows which type of equation is this? Oh, it's written wave equation. So it says that electromagnetic wave equation does not retain its form under Galilean transformation. So what is the Galilean transformation, by the way? So this is S prime is moving. Suppose the coordinate of S prime is x prime comma t. Suppose S prime is also moving at speed v, then this x prime will be equal to x minus vt. Everyone agrees? Y prime is equal to y, z prime is equal to z, and t prime is equal to t. Okay. Now we need to find d phi by dx square. D2 phi by dx square. So first let us find what will be d phi by dx. So d phi by dx, we can write it as d phi by dx prime, dx prime by dx plus d phi by dy prime, dy prime by dx plus d phi by dz prime, dz prime by dx plus d phi by dt, dt by dx. Everyone agrees here? If our we do not know if our x is function of x, y, z, t. If we assume that our x is actually a function of x prime, y prime, z prime, and t prime. Now we know that actually it's not correct. Our x prime is only function of x and t. So dx prime by dx, if we see from here, dx prime by dx is equal to 1. So this part is 1. dy prime by dx is actually how much?
C.
0. Same way this one is 0. dt by dx,
Uh,
here I forgot to
0.
write. 0.
Hmm.
So finally we got that it is nothing but d phi by dx prime, right? Right. Next, same thing if you do d2 phi by dx square, we will, what we have to do, dd phi ddx of d phi by dx prime. Now similarly if we do, it will come out to be equal to same thing, d2 phi by dx prime square. Everyone agrees till here?
Yes, Bhaiya.
Okay, good. So d phi by dy now. d phi by dy, if you again simply write same thing, so dy prime by dx will become 0. No, dy prime by dy. Okay, let me write d phi by dx prime into dx prime by dy plus similarly two terms, right? So this term is 0 because y prime is x prime is not having any y dependency, so 0. Y prime is dy prime by dy will become 1. This term will become 0 and this term will become 0. So this will give us d phi by dy prime. Similarly, we will get d phi by dz to be equal to d phi by dz prime, which implies d2 phi by dz square will also become d2 phi by dz prime square. But when we write this term d phi by dt, it will not be same. Now let us see. So this term will become d phi by dx prime by dt, d phi by dy prime, dy prime by dt. Just stop me if you have any confusion. dz prime by dt, d phi by dt prime, dt prime by dt. Now what is dx prime by dt?
Minus V.
Minus v. So this will become minus v d phi by dx prime. What is dy prime by dt? Del y prime by del
0.
t?
0.
0.
0. 0.
Del z prime by dt? 0.
0.
Del
0.
t prime by del t?
1.
1.
1. So finally we got that this will be del phi by del t prime. It's like if we do del t, it is nothing but doing like this, del x prime plus del t prime of phi. It is doing like this. So if we do 2 times of derivative of this, then what it will become? Again same thing will come out. X prime plus del t prime of which quantity now? This quantity. Everyone agrees here?
Okay.
So finally we will get that this is equal to v square del 2 phi by del x prime square
I think
plus,
that's plus symbol is there. First one is plus.
oh yes, sorry, there is a
No,
plus.
no, no, that is correct. Here. That is correct. On the last step, you are right. That is minus the last step plus V square.
Oh sorry, yes. So here it is v square plus d2 phi by dt prime square minus this v into this term will come 2 times, so v into d2 phi by del x prime del t prime.
So
Everyone
minus 2,
understood this?
minus
Minus
2V,
2, 2
2.
times it will come. Now, if we write the left hand side, like d25 by dx prime square plus d25 by dy prime square plus d25 by dz prime square minus 1 by c square d25 by dt square prime square, then we will see that x square plus d25 by dy square plus this 4 times plus some additional terms like this v square by c square, like there will be some additional term. We know that this part is actually 0. It's already given. This part is 0. But this additional terms will be there, making it not equal to 0. Okay. That means this wave equation is not retained under Galilean transformation.